Alrighty gang, let's rock and roll through chapter 9 revision. First question, the value of an annuity after n months payments of $55 have been made, so we're paying off 55. You can see that there in the equation. Can be determined using the recurrence relation here. The value of the annuity after 5 payments have been made is closest to what? Okay, so easiest thing here, jump over to our CAS. I'm going to put in the initial value of the annuity, so 100,000, and no, I don't want to do that yet. I want to do this, go there, so that recognizes that as the answer. Then I'm going to do the equation and just put the answer in for the place of Vn. Okay, so if I come over here and do 1.0025 times my answer, okay, and then subtract 555. Okay, and I want it 5 times. So that's the first time, second time, third time, fourth time, fifth time. So we get a value of 9, 8, 4, 6, 7, and 36 cents. Doesn't matter about the cents. Once we do that, closest to, so what's the closest to? It's close to 98467. It's closest to C by a long shot. Okay, oh, I guess all of them are around that, but you can see without our cents there, we are definitely closest to C. Okay, consider the recurrence relation below, and we want to know the recurrence relation could be used to model what. So it's about describing what's happening here. So a couple of things we want to pick up on. Whatever it is, we've got 10,000 of something, and the value of that we're adding to, so we're adding $500. Doesn't say what period it's over, $500, and then our R value also has 4% added to it as well. So whatever happens, we are making this value bigger, okay, as well as the bank, assuming it's something to do with that, is giving us 4% on it, something like that. So, you know, it's unlikely there's going to be a loan or something like that, but this is growing, whatever that is. Now that could be a negative maybe, but let's have a look at the descriptions. A reducing balance depreciation of an asset initially valued at $10,000. So we know it's not that because it is going to be increasing in price. So this is the original value of the asset. These would need to be reducing somehow to allow that. And then we've got this payment here anyway, so you can't artificially, I guess, add to the value of something in a reducing balance depreciation. B, a reducing balance loan with periodic repayments. Okay, so a reducing balance loan, if this was our loan, $10,000, this would want to be a negative. Okay, to reduce it, the interest could stay as it is because that would be the bank adding to its portion. So we're not going to go with B. A perpetuity with periodic payments of $500 from the annuity. So we could do that by, we could check that out. What do we got? By having a look at what's 1.04. Actually, it can't be that. I'll tell you why right now. So if we're getting 4% on this and it was a perpetuity, we'd be needing to take that 4% off, and that wouldn't have to be a negative again. The plus there would have to be a negative, so it can't be a perpetuity. An annuity investment with periodic additions of $500 made to the investment. Okay, so it could be that. So we're investing with $10,000 in the bank. The bank's giving us 4%, and we're still adding $500 a month, a week, a year, whatever it might be. So it could be that. We'll just double check the last option. An interest-only loan of $10,000. Okay, so an interest-only loan of $10,000 would mean that we have to pay back the interest that we are charged by the bank. So if the bank is charging us 4%, we would need to subtract the $500 off that 4%. So it can't be that. So if this is 4%, that works out to $10,040 or something like that. $10,400 even. Then we would need to subtract that amount off it. Okay, so it can't be that either. So we have to roll with D. Alrighty, let's blow this one up a bit. Okay, Alex sold his business mechanics business for $360,000 and invested this amount in a perpetuity. Okay, pretty important that. The perpetuity earns a rate of 5.2% per annum. Interest is calculated and paid monthly. Okay, so perpetuity means that whatever interest is made is the amount of interest that is paid out, so that the value, that $3,600, never changes. What monthly payment will Alex receive from his business? So we just need to work out what 5.2% of $360,000 is on a monthly basis. So we can do that by going with 5.2 divided by 12 to get to a monthly rate, over 100, so it's not a percentage anymore, it's a decimal, and then multiply that by 360,000. Okay, over here, just run through that. So 5.2 divided by 12, divide that by 100, times that by 360,000. Just checking if I've got enough zeros there. Yep, all good. And his monthly income is $1,560. Scroll across. Later, Alex converts the perpetuity to an annuity investment. And we get 3.8% per annum now, compounding monthly. For the first 4 years, Alex makes a further payment each month of $500 to his investment. This monthly payment is made immediately after the interest is added. Okay, that's cool. That's how we calculate it anyway. After 4 years of these regular payments, Alex increases the monthly payment. This new monthly payment gives Alex a balance of $500,000. Okay, so he wants to hit that after 2 years. Okay, what was Alex's new monthly payment? Okay, to the nearest cent. Alrighty, so we need our financial calculator for this. There is no way around it. Let's have a look at this now. Financial, let's clear all that. Give me that one back, please. Alrighty, so first thing we need to do, because it's got a changing circumstance in it, or a changing of conditions, we need to set out what the original conditions were and know what he has. So the first 4 years makes a further payment. So we need to know what he's got after the first 4 years. Alrighty, so our N value, N, I, PV, PMT, FV, and PYCY. So what do we start with? Well, we know that the N, so compound monthly the first 4 years, is 48. So 4 years, 48 months. His interest during that time was 3.8%. His present value is He still has 360,000 left over, but he puts that in the bank, so he's got negative 360,000. Remember, he's giving it to the bank. It's negative, and he also pays them $500 a month. Whoops, not 5,000, 500. My mouse is super glitchy today. So 500. Then we've got future value. Now, future value we're going to solve for, and both of these are 12. We'll pop over to our CAS. 48, 3.8, negative 360. PMT is negative 500. Future value is what we're solving for. Okay, so that's all we get. Now we haven't finished yet, that's just the first portion. So what we've got is he has two, tell you what I haven't done, and you would have seen it right there. These aren't 12. We need 12 there, and 12 there. Solve again for future value. Yeah, that didn't look right. And so we've got 4, 4, 4, 8, 7, 2.9, 4, 4, 5. Okay, so now we know a few things change here. We know that he wants to get to a balance of $500,000. So we're going to re-put in everything, and that's going to be after a further 2 years. So looking at that, our next calculation is after n equals 24. I is still 3.8, that hasn't changed. PV is now that value there. Payment, we don't know, so we're going to solve for payment. Future value, we know it's $500,000. Okay, and both CV and PY are 12 each. Okay, so over in our CAS, we can get rid of this, copy our future value up to the top there, make sure that it's still a negative because that's money that he's got invested in the bank, so he's given that to the bank. We've got a $500,000 future value that we need, and we don't know what the payment is. So if we solve for that now, we get, actually we've got to remember that that N is a 24, so check that we've done everything. Payment, solve for that, is 805. Okay, so over here, and to the nearest cent, so it's payments are, let's make that red, 805 and 65 cents. Okay, and that is how much you like to put in for the next 2 years on a monthly basis to make it to $500,000. Right, just make sure it's good. You can see it's good to write down like I did here and here, because when I went across here and I go, oh, I messed up the 48 on that last step, I haven't changed it back to 24. It's good to just write down just for your own mental computations as you go through, just to double check. We're all good there. And be careful, even though that says negative 805, that's because we're paying the bank something. In real life, we would call it an $805 payment if you're going to write that down. And we got last question, 5 lines of an amortization table for reducing balance loan with monthly repayments are shown. The interest rate for this loan changed immediately before the 28th repayment. What can this be described as? So what we have to do here is look at the interest we'll charged for this 28th repayment and compare it to what we'll charge to any of the previous ones, but we'll just do the 27th. So if we want to look at that, and that's charged on the monthly, on the previous balance. So we do 1,002.26 divided by the previous balance. We'll go back to our CAS. So 1,2.26 divided by, where am I? There. 22778.5.76. Okay, and we want to times that by 100 to get it as a percentage. So the interest we're charged on this 28th repayment is 0.44. Now we're going to look at the interest that we got charged in the 27th repayment. So we're going to look at this as a percentage of that. And we've got 961.90 divided by 229,023.86 and times that by 100 to get the percentage. And we get, where am I? 0.42 rounded. Okay, now they are monthly figures. Okay, so that's each month. You can see all of our answers here are what does it equate to, but they've all got per annum. Okay, so we need to think in terms of per annum. We can see that here, to start with, it's gone up. All right, it's gone from 0.42 to 0.44 a month. Now, what does that equate to per annum? We want to go, okay, we can see that the difference is 0.02. So 0.02 times 12 to get it over a year is the same as 0.24%. Okay, so that's a 0.24 increase because we can see it's going up. And increase, so first one comes up with it straight away. 0.24, it's the only one with 0.24 there. We know it's an increase, so we could get rid of any of the decreases anyway. Alrighty, and that is all done for that one. Okay, and we're all good there. Got something in the throat. Good finish. Okay, hope that helps, guys. See you next time.